Alright guys, today we're going to be talking about writing and graphing direct variation. Alright, so what is direct variation? Alright, so direct variation is a special type of linear function. Alright, so it's linear. And it's a relationship between two variables x and y. Alright, and it can be written in the form y equals kx. Okay? And in this equation, okay, y varies directly to x. Okay? So, to kind of recap here, direct variation is a linear function, a special type of linear function. Okay? And y varies directly as x. And this k here is called our constant of variation. So we call this constant of variation. Okay. And if we look at the problem, it says y varies directly as x. So when you hear that, you know that we're dealing with a direct variation problem. All right, so we can go ahead and go to this equation. All right, so again, it tells us y varies directly as x, so you know that we can use this direct variation equation, right? And it says y equals 14 when x equals 3.5. So what we want to do here is plug those values in to our direct variation equation and solve for our constant of variation. So for example, when we plug this in, we're going to have here, let's do this in a different color. So we said y equals 14, so we're going to plug a 14 in here. Okay, we don't know what k is, we're solving for k. And then we'll have 3.5. Okay, so at this point what we want to do, right, we simply want to divide 14 divided by 3.5. Okay, and when we do that, so we're going to divide each side by 3.5. Okay, and 14 divided by 3.5 is going to give you 4. So k here equals 4. So we can write this, okay, as a direct variation function. Right? So we can rewrite this as y equals 4x. So I just simply replaced the k with what we found here, and we left the y and the x. So we can go ahead and test this out, right? When I plug in 3.5 into this direct variation equation, right, I should return a 14, right? 4 times 3.5 equals 14. So it checks out. We can then graph this linear function on a graph. So why don't we go ahead and do that? So again, going back to y equals mx plus b, right? When we go to graph, we always start with our b value first, which is going to be on the vertical axis. And we see here that it's 0, so we make a point at 0. And then we go ahead and graph our slope, which is going to be rise over run. So this is really 4 over 1, right? Our m value, 4 over 1. So we're going to go up 4, 1, 2, 3, 4, and then over 1. Okay, and we can go ahead and graph this guy. All right, and there is our direct variation. So we wrote it out, and we also graphed it. All right, let's try another problem.